Hi everybody, this is Eduardo Suarez. Today we're going to look at a common mistake in iRVision and I'm going to show you how to fix it. On my iRVision videos I mentioned many times that there is a workflow that you need to follow. Basically the workflow is a series of steps that you need to follow to get the proper vision configuration. Let's review these steps. First, you need to make sure that you have the proper robot mastering. Then you're going to select your camera. Then the next important steps are setting the user tool and user frame, and this includes the application frame and the offset frames. Then you're going to set the calibration grid frame, configure the camera calibration and the vision process, and then you need to create your program and test it. I'm going to highlight these steps in here, setting the user tool and user frame, and setting the calibration grid frame. Let's say that unintentionally you make the mistake on this part of the configuration and you are not aware of this mistake. Let's say, for example, that you wrongly set up the robot TCP, or you're using the incorrect TCP for calibrating the grid frame. Or another example could be that you took the wrong points on the calibration grid. So if for any reason you end up with the wrong calibration grid frame, the end result is that you're going to have a bad offset data because the translation of the points of the part on the calibration grid relative to the reference position is going to be incorrect, and as a result the offset data on the offset frame is also going to be incorrect. I'm going to show you now how to identify this mistake and how to fix it. We're going to start with a work cell that I have already created on one of my previous videos. In this iRVision 2D configuration, we have a fixed frame offset with a row mounted camera. We're going to open the teach pendant. We're going to go to menu, setup, frames, and here you're going to see the user tool number 1. That's the one I'm using for the gripper. In this case, it's a pointer. And we're going to go to the user frames, and we're going to have the user frame number 1. That's the offset frame. And we're going to have the user frame number 2. That's the calibration grid frame. If you have already watched this video, you may remember that I used the automatic calibration grid frame setting instead of using the touch-up method. So in this way, we can have a more reliable calibration grid frame without introducing the human error of touching up the points on the calibration grid. For that, what I did, we go to menu, iRVision, Vision Utilities, and I use the calibration grid frame setting. If we go to details, you're going to see here that I use user frame, and the user frame selected was number 2. We're going to take this work cell and we're going to rename it. And the first thing we're going to do, we're going to select the robot. We're going to go to properties. We're going to go to serialize the robot on the general tab. We're going to say OK. And we're going to select in here the robot options. And in robot options, we're going to select vision, and we're going to go to vision support tools, and we're going to select the option package J873. We're going to press next, and we're going to press finished. We're going to go back to the work cell, and over here we're going to select apply. And on the pop-up window, we're going to select reset as robot, and what it is going to do is going to cycle power the controller. Once this is done, we're going to select OK, and we're going to close the window. Now we're going to simulate that we have a wrong calibration grid frame, and for that we're going to open the teach pendant. We're going to go to menu, setup, frames, and we're going to select the user frames, and we're going to select user frame number 2. We're going to make some changes. We're going to select the X axis, and we're going to change this value to 1575, and we're going to select this one in here, the axis Y, and we're going to put another value. We can select something like a 15. In this case, we're just making a shift on the X and Y. We don't need to make any rotation. Now we're going to be the calibration grid visible. We're going to select the table. We're going to select the part, and we're going to make this one invisible. We're going to select the grid, and we're going to reposition the calibration grid. And now if we select the user frame number 2, you're going to notice that the user frame for the calibration grid is shift from the system origin for the grid. So in this way, we're going to simulate that we have a bad setting for the calibration grid frame. We're going to go to Robot. We're going to go to Internet Explorer. We're going to select iRVision, Vision Setup. And now we need to apply these changes. So we're going to select the camera data, camera 1. We're going to edit. We're going to go to calibration grid location. And notice the values that we have in here. This was the values for the original calibration grid frame. Now we're going to press set, and we're going to press OK. And you're going to notice that the values changed, and the changes that we have right now are the changes that we did on the calibration grid frame. We're going to press save, and we're going to end the edit. Now we need to go back to the work cell. We're going to make the calibration grid invisible. And we're going to put the part back in place. Now we need to move the robot to the vision position. We are already there. We're going to select data. We're going to select the position register. We're going to select position register number 2. We're going to make sure that we have the user tool number 1, and user frame is going to be 0. And we're going to move to that position. So we are already there. Now we're going to go back to the iRVision. We're going to select the vision process. We're going to edit, and we're going to go to the offset data calculation tool. And you're going to see now that the reference point that we have for the part is going to change. We're going to take a snap. The part didn't change in position, and we're going to press set. We're going to press OK, and now we have our new reference position for the part. We're going to press save, and we're going to press end. Now we can go back to the work cell. We're going to open the TP program, and we're going to touch up the point. We're going to run in step mode. And we can see that we already adding the point. So we don't need to touch up anything. We're going to continue running the program. And we're going to go back to the beginning. We're going to select in here the vision register number 1. And the next thing we're going to do, we're going to move the part with a new calibration grid frame. We're going to select the table. We're going to select the part, and we're going to move the part on the X and Y. So we're going to put some values in there. And we're going to run the program again. Notice now that we have an offset on the X and Y. We're going to keep running the program. And we're going to go to the touch position. You're going to notice that even though we change the position of the part, we're still able to go to the same position. We're going to continue running the program. And we're going to go back to the beginning again. So now what we're going to do, we're going to do a rotation on the part, and we're going to select something like 10 degrees. And we're going to run the program again. We're going to go to the vision position. We're going to run the vision process. And now we have an offset on the rotation. We're going to keep running. We're going to go to the touch position. And let's look now what happens. So now when we change the rotation for the part, we are not able to go back to the same position. So now we have an offset. So this is the way that you're going to identify that you have a problem, that something is not right, that you made a mistake at some point during the calibration grid frame setting. So we need to find a way to correct this offset. So for now, we're going to go back to the home position. We're going to keep running the program. And now we need to make changes to our TP program. The program that we're going to use now is a KAREL program, and it's part of the Vision Support Tools option package that we have already installed. The way that we're going to call this program is as in showing here. It needs 5 arguments. The first argument is the type of resistance stored in the offset data. We're going to set to 1 if we are using a vision register, and we're going to select 2 if you're using a position register. The second number is a vision register or position register number, and this one specifies the number of the vision register or position register stored in the offset data. The third argument is a position register number, and this one specifies the amount of the adjustment. The fourth argument is going to be a vision register or position register number again, and this one specifies the vision register or position register to store the adjusted offset data. So this one is going to be the result of adding the vision register in here plus the adjustment that we're going to make over here, and these two combined is going to be stored on the argument number 4. And finally, we're going to have an argument number 5. That's going to specify the register to store the error number. And this parameter is optional. So what is going to happen if we run the program and we find any error, the error code is going to show on the argument number 5. We can look in here on the table all the error codes that we can have. 0 means that the program ran normally without any problems, and any other number is going to indicate the reason for the error code. So we can use this one for troubleshooting. After that, we're going to have 2 more lines. We're going to have a line that is going to be looking at the argument number 5, and this is different from 0. We're going to jump to a label, and we're going to end the program. Otherwise, we're going to go to our position, that in our case is going to be the touch position, and we're going to use a vision offset. But in this case, instead of using the vision register number 1, we're going to use the vision register number 2. That's going to be the 4th argument. So we're going to go back to our program now, and we're going to make some changes. The first thing we're going to do, we're going to go to menu. We're going to select next, system, variables, and on variables, we're going to look for around item number 300. We have to make sure that the KAREL enable system variable is set to 1. Otherwise, you're not going to be able to call a KAREL program from a TP program. We're going to go to our TP program, and we're going to add 2 more lines. The first line is going to be a call to the KAREL program. So we're going to select instructions. We're going to select call. We're going to select call programs. And in here, we're going to select collect KAREL programs. And we're going to select the adjust offset. And now we need to add the arguments. For that, we're going to select choice, and we're going to add the arguments one by one. Let's review what we're doing here. The first argument is going to be a vision register. The second argument is going to be vision register number 1. It's the one that is going to get the offset data. The third argument is going to be position register number 10. That's going to be the additional offset that we need to add. And the fourth argument is going to be vision register number 2. Is the vision register that's going to get the result of adding the offset from vision register number 1 plus the additional offset from the position register number 10. And finally, the fifth argument is going to be register number 3. That's going to contain the error code. So now we're going to select the if instruction, and we're going to be looking for the status of register number 3. We're going to select register number 3, and if register number 3 is different from 0, we're going to go to a jumped label number 99. That's going to be the same label that we're using in case that we fail with the vision get offset. So finally, what we need to do, we need to change in all the move instructions where we have vision register number 1, we're going to change it to vision register number 2. Now we can add some description to our program. We're going to select vision register number 2, and we're going to give it a name. We're going to select registers, and we're going to go to register number 3. And we're going to do the same with the position register number 10. One more thing, that position register number 10 is not initialized, so we're going to put all the positions to 0. And we're going to go back to vision register number 1. So now the next thing that we're going to do, we're going to move the part. We're going to select the part in here, and we're going to go back to the reference position. And now what we're going to do, this one has to be 02. Now what we're going to do, we're going to rotate the part 180 degrees. One more thing that we need to do, we have to make sure that we're going to be able to find the part. So we're going to run the program, and we're going to position the robot on the vision position. Now we're going to go to robot, we're going to go to Internet Explorer, and we're going to go to vision setup. We're going to select the vision process. We're going to do an snap and find, and we couldn't find the part. So one change that we're going to do, we're going to go to the GPM locator tool, and we're going to make some adjustment. We're going to change the elasticity. We're going to select 3 pixels, and let's see if we can find the part now. We were able to find the part, so we're going to save, and we're going to end the edit. We're going to go back to our program, and now we're going to continue running the program. You're going to notice that we got the offset on vision register number 1, and we have a rotation of 180 degrees. Now what we're going to do, we're going to go to pick the part. We haven't made any adjustment yet to the additional offset on position register number 10. And you can notice that when we go to touch the part, we have a significant offset from the position that we're going to go. So now we need to find out how much is this offset that we have in here. Something that you have to notice that we are on the user tool number 1. That is going to be our offset frame. So what we're going to do, we're going to select position register number 11, and we're going to save this position. Now we want to move the pointer to the point that is going to be our touch point. And we want to record this position. So now we need to look at the difference in the position that we have to the position where we want to go. For that, we can look at the position on the position register. This is position register number 11. And this is position register number 12. We're going to take this information and we're going to put it on an Excel sheet. So this is information that we have for the position register number 12 on the X and Y, and the position number 11 on the X and Y. And this is going to be the difference between the two positions. You have to make sure that when you're looking at X and Y, you're looking at the orientation for the offset frame. So now we're going to take this difference in position and we're going to divide it by 2. And we're going to take this result and we're going to put this information on the position register number 10. We're going to go back now to position register number 10. And we're going to change from 0 to the value that we got from the Excel sheet. We're going to accept these changes. And now we're going to run the program again. We're going to go in step mode. We're going to go to the vision position. We're going to run the vision process. We're going to get the result on vision register number 1. And now we're going to add this information to the vision register number 2. So vision register number 2 is going to have vision register number 1 plus the position register number 10. And now we're going to continue running the program. We're going to go to the touch position. And you can notice that we are dead center on the touch position. So with this position register number 10, we were able to correct the offset that we had originally. We're going to keep running the program. We're going to go back to the beginning again. Now what we're going to do, we're going to position the part back on the reference position. And we're going to run the program again. We're going to go to the vision position. We're going to get the vision offset. Now the rotation is 0. And we are adding the additional offset from position register number 10. But in our case, the vision register number 1 is 0. So vision register number 2 is also 0. And we have a 0 offset. We're going to go to the touch position. You can notice that we go to the exactly same position. We're going to finish running the program. And we're going to add another rotation. And we're going to run the program again. This time we get a new offset data. And we're going to go to touch the point. And we're still in the same position with just a small offset. So this way you know how to use the position register number 10. So originally you select the value 0. You rotate the part 180 degrees. You're going to calculate the offset from the position that you are to where you want to go. From that offset, you divide it by 2, and that is the value you want to adjust on the position register number 10. In conclusion, you need to be very careful and pay special attention when you configure the user tool and user frame and the calibration grid frame. There is a way to identify that you made a mistake. If you move your part on the X and Y without any rotation, and you're able to get the correct offset data, and then you rotate the part and you get a bad offset data, that means that your problem is more likely on the calibration grid frame setting. I show you that there is a way to fix this offset problem using the KAREL program, adjust offset, but this is only a band-aid that can help you temporarily, and you really need to address the root cause of the problem. Also, be aware that if you want to use this KAREL program, you need to have the option package Vision Support Tools installed. I'm going to leave the link to this work cell on the description below, and thank you for watching.